Okay, we're going to go through a tutorial on how to solve logarithmic problems, all right, using logarithmic differentiating logarithms. So, first thing you have to remember is that the derivative of the natural log of x equals 1 over x. That is one of the key things to do this. Many tutorials on how to proof behind this pretty easy because exponentials and logs are inverse of each other. So this is what we get. Another one that students always forget is how to find the log of base of b or a of x. The derivative of this is going to be 1 over x times the natural log of b, the base. All right, or sometimes people call it a, but that's what you have to remember. So we're going to go through some problems and applying this principle. So for example, if I would have y equals natural log of x squared. Okay. Once again, we're going to use a chain rule. Well, what we have is y prime is going to equal, well, we take the derivative of the outside, which is natural log. It's 1 over x squared. Times now the derivative of the inside, which is going to equal 2x. So we would find out the answer would be equivalent to, all right, 2 over x squared, which we know is going to equal 2 over x. Now here's our answer. Let's try another one. All right, hopefully that makes sense. Let's say I have y equals the natural log of something 2x plus 2. 2x plus 2. All right. In this one, we're going to have y prime equals, well, once again, chain rule. All right, when we get the chain rule, we're going to take the derivative of the outside. So natural log is quantity 2x plus 2 times now the derivative of the inside function, which would be 2. So our answer is going to be 2 over 2x plus 2. Factor out the 2's on that. We have 1 over x plus 1. And that could be a simplified answer. Okay, well, hopefully you're starting to get the hang of this. We're going to try some more. All right, let's say I have, I don't know, let's go like this. Y equals natural log of 2 minus cosine of x. We have y equals, once again, use a chain rule. Use a chain rule, take the derivative of the natural log, which is 1 over 2 minus cosine of x, because it has to be, all right, 1 over the quantity inside. Now times derivative of the inside, which is, derivative of 2 is 0, and we have derivative of negative would be negative times the negative sine of x, make it positive, so we'd have 1, actually, sine of, let me erase that, sine of x over 2 minus cosine of x. And that would be our simplified answer. Okay. Hopefully this is starting to make a lot of sense. Let's try one more. Y equals, at least we're using natural log of the quantity 10 over x. That part right there. Okay. First, I'll probably change this to the natural log of 10 to x to the negative first. But once again, take the derivative using 1 over 10 to x to the negative first times now the derivative of the inside, which would be negative 10 x to the negative second, and that's what we would have. We could simplify this. The 10s would cancel out. We would have this go on the top, so we have x over negative x over x squared, which would be negative 1 over x. Here's the final answer. Okay, so that is using the natural log. Let's talk about some where we have other bases, right? Then other than just e. So, for example, when we're doing this, once again, if we take the derivative of something, a log base other than e, like b, it's 1 over x, whatever the quantity is inside, times natural log of b. Right? So if we would have like a problem like y equals log base 4 of x squared. Once again, you have to use chain. Take log base 4, that would be 1 over. So what we're doing now is we're going to have to take and we're going to put x squared in the bottom and make sure you multiply by the natural log of 4, which is the base. And then we're going to take and multiply by all right, x squared or x to the inside function, which is 2x to finish the chain rule. What we then have is, we can simplify this, x will cancel out, so we have 2 over, and this will cancel out to 1, and we have is x, and that is going to be our derivative. Well, we'll do a couple more. We're going to do a couple more, and what we have is, let's try this, y equals log base 3 of 1 plus x natural log of 3. And what we're going to do, so we have y prime, we have a log base of 3, so we use a chain rule again. So we're going to take the derivative of the outside function, which is log base 3. So the derivative of log base 3 is 1 over 1 plus x natural log of 3 times the base, natural log of the base, which would be natural log of 3. Finish the chain rule by, now we have to take the derivative of the inside. Derivative of 1 is 0. Derivative of x times natural log of 3. Now, natural log of 3 is a number. This is a constant. So essentially, we're taking the derivative of x natural log of 3, which would give us then natural log of 3. Okay? Because when you take the derivative of this, this is similar to taking the derivative of 3x. That's where a lot of students screw up. The answer is 3. A lot of students see the natural log of 3 and they want to write 1 over 3. That's not correct. All right. This is similar to doing that. So when you have this, the derivative of x natural log of 3 is just going to be natural log of 3, because natural log of 3 is a constant, and that's where you get the answer. From here, we can cancel out, boom, boom, and we have 1 over 1 plus x natural log of 3 is going to be our final answer. All right. Well, we went through several different examples of finding derivatives of logarithms, ones with bases of e, and also ones that have bases other than e. I hope this helps you out on how to solve problems using logs. Just remember, okay, when you're finding these, that the derivative of a natural log is 1 over x, and the derivative of log base b of x is 1 over x times the natural log of the base. All right, and that's in the bottom. All right, so good luck and God bless in the rest of your problems.